Hello, and welcome to Lesson 4.1b, Graphing Linear Functions. Our objective for today is that I can graph linear functions by using the x and y intercepts. Now, we're going to start with examples 3 and 4, which are graphing y is equal to a and x equals to a equations. So if we look at our first example here, we have the equation y equals 2. And I'm going to set up my starting values that I used yesterday. So we have -2, -1, 0, 1, and 2. And I'm going to see what happens when I substitute those values in for x in the equation. So in this case, we have -2 substituted for x is going to give us a y value of 2. And if I substitute -1 in for x, I'm going to get a y value of 2. Well, then I'm totally going to get something different because obviously I'm substituting in 0, and I'm going to get a y value of 2. Okay, substitute in 1, and my y value is going to be equal to 2. And, okay, fine. We're going to substitute in 2, and we're going to get out 2. So if I graph those 5 points, we've got -2 and 2, 1 and 2, 0, -1 and 2, 0 and 2, 1 and 2, and 2 and 2. I see that I have a very clear horizontal line, and I make sure that I draw it to the edge of the grid, and I have arrows on each end. So a y equals graph, when y is equal to a constant, remember a constant is unchanging, it's permanent, so that means our y value is also unchanging at a value of 2, and we see that in a graph as a horizontal line. Now, if I look at letter B, my x value, so my equation here, well, I'm going to substitute in. I'm told that x is going to be equal to 2. So 2, well, what y value does that give me? It can give me any y value. So 2 and 2. If I substitute in 2 for x, I could get in a 1 for my y value. If I substitute in 2 for x, I can get a -1 for my y value. If I substitute 2 for x, I can get 0 for my y value. If I substitute 2 in for x, I can get -2 for my y value. Right? Y values are they're any number. You can have any y value no matter what, it's still going to have an x value of 2. So again, if I graph these points, we have 2, 2, we have a 2, 1, we have a 0, 2, or 2, 0, 2, -1, and 2, -2. And so an x equals equation is going to look like this, where you have a vertical line. No matter what, your x value is constant at a value of 2. So no matter what your y value is, your x will always be 2, and the way we see that is a vertical line. Now, I do have two u-try equations for you. Letter C is x equals -7. Letter D is y equals -3. I would like you to graph both of those equations now, and then check your work against mine. Letter C, x equals -7. I know this is going to be a vertical line at the point of, an x-intercept of -7, I know it's going to be a vertical line because it's x equals, so x will always be 7, and so it looks just like that. Vertical line, arrows on the ends. Letter D, we have y equals -3, so my y-intercept on this one is at -3, all the way down here. And if I were to graph that, I know my slope, we can think of this as being in slope-intercept form where my slope is 0, so we're not going up or down at all. And so we have just a horizontal line where the y value is always going to be -3, and it will never change. Now, this lesson is all about graphing using x and y intercepts, but we're going to start off by just kind of teaching you and reminding you what is it to find an x-intercept? How do we do that mathematically given our problems? So if we look at this equation, we have 5x minus 6y is equal to 60. So the first step to do is we're going to find our x-intercept. So to do that, we substitute in 0 for y, right? Because when we are crossing the x-axis, our x-intercept, our y value is 0. So the middle term there cancels out, and we're left with 5x is equal to 60. We divide both sides by 5, and x is going to give me 12. Now, if I want to find the y-intercept, because I need at least 2 points if I'm going to graph a line, right? That's the absolute minimum that we can have is 2 points. We're going to substitute in 0 for x, and we are going to solve for y. So again, that term cancels out. I'm left with negative 6y is equal to 60, which I divide by negative 6, and my y value is equal to negative 10. So those are my two intercepts. My x-intercept is at 12, my y-intercept is at negative 10. And I can use those 2 points, and I can draw the line between them, and it extends beyond them, and there we go. We can graph that way. So if we look at letter B, we have an equation, 3x plus 8y is equal to 12. Again, I'm going to solve for my x-intercept first. So we have 3x plus 8 times 0 is equal to 12. 8 times 0 cancels out, and I'm left with 3x is equal to 12. And I'll divide both sides by 3, and x is equal to 4. To find my y-intercept, I substitute in 0 for x. I have plus 8y is equal to 12. Now, the 3 times 0 cancels out. I'm left with 8y is equal to 12. And now I'm going to divide both sides by 8. And when I simplify 12 over 8, it reduces to 3 over 2. And so my intercepts are x equals 4 and x equals 3/2. All right. At the top of the next page are 2 U-Try problems that I want you to do on your own, and then check your work against mine. The first U-Try problem, example C, is 2x plus 6y equals 18. So my first step is going to be to find my x-axis, my x-intercept. So we have 2x plus 6 times 0 equals 18. You'll notice I still continue to substitute in my value in parentheses just so that I remember that we are doing multiplication in that step. So we're left with 2x is equal to 18 after 6 times 0 cancels out. And then we divide both sides by 2, and x is equal to 9. Now, my y-intercept, we substitute in 0 for x, and I have plus 6y is equal to 18. So now, the 2 times 0 cancels out. I have 6y equals 18. And I divide both sides by 6, y is going to be equal to 3. All right, letter D, we have 6x minus 3y is equal to 36. So I'm first going to find my x-intercept. You don't have to find the x-intercept first all the time. I just do because in the ordered pair coordinates, the x comes first. That's just why I do it. So we cancel out 3 times 0. And so we have 6x is equal to 36. And we divide both sides by 6. And so x is going to be equal to 6. To find my y-intercept, we substitute in 0 for x, and we're multiplying that by 6, and we have minus 3y is equal to 36. First step, that cancels out. I'm left with negative 3y equals 36, and I divide both sides by negative 3, and I find that y is going to give me negative 12. All right. So now, example 5 is going to be taking that step and applying it to the skill of graphing. So we are going to find our intercepts, and we are going to graph our equation based upon those intercepts. So for letter A, I'm going to find my x-intercept first. So we have 2x plus 5 times 0 is equal to 20. 5 times 0 cancels out, so I'm left with 2x is equal to 20, which I divide both sides by 2. X is going to be equal to 10. Okay. Now, my second point, I'm going to substitute in 0 for x. So we have plus 5y is equal to 20. That cancels out, so 5y equals 20. Divide by 5, and y is going to be equal to 4. So if I graph y equals 4, that's my y-intercept. It's at 4 on the y-axis, up and down. And if I graph 10 for my x value, that's right over here. And if I'm going to draw this in as a straight line, I'm going to draw my line through those points, and I have my equation graphed. Arrows on the ends of the line, and make sure it goes to the edge of the grid. Now, letter B, we have 4x minus 3y is equal to 12. Again, I'm going to solve for my intercept. So 4x minus 3 times 0 equals 12. 3 times 0 cancels out. So 4x is equal to 12. Divide by 4. X is equal to 3. My y-intercept, we have 4 times 0 minus 3y equals 12. And 4 times 0 cancels out, so we have negative 3y equals 12. Divide by negative 3. Y is going to be equal to negative 4. So I can graph that. My y value is at negative 4, so I'm down 4 to the right 0. And my x value is going to be at positive 3. And I'm just going to connect those points with a line. And there we go. My arrows are at the end, and it's to the edge of the grid. All right, there are now 2 U-try problems for you to go through. Letter C is negative 3x plus 5y equals 30. Letter D is 4x plus 6y is equal to 24. I want you to do those on your own and then check your work against mine. All right, letter C. We have negative 3x plus 5 times 0 is equal to 30. 5 times 0 cancels out, so we have negative 3x equals 30. Divide both sides by negative 3, x is equal to negative 10. Okay, and I can put that point right away at negative 10 for x. Now, to find my y-intercept, we have negative 3 times 0 plus 5y is equal to 30. Negative 3 times 0 cancels out. 5y equals 30. And we divide both sides by 5. Y is equal to 6. So my y-intercept is at positive 6. And again, I'm going to draw my line in connecting these 2 points. Okay, your line should be a straight line. You're either using a ruler or some other straight edge, or if you're doing it digitally, you are using a line tool and making sure that your line is nice and straight, making sure it goes through the points that you've identified. All right, letter D, we have 4x plus 6y equals 24. So we're going to start off. We have 4x plus 6 times 0 equals 24. And when that cancels out, we have 4x is equal to 24. Divide both sides by 4. X is going to be equal to 6. So we can put our point at 6 on the x-axis. Now our second one, we're going to have 4 times 0 plus 6y equals 24. 4 times 0 cancels out. 6y equals 24. Divide by 6. Y is equal to 4. So we have our point at 4. And now we're going to just connect our dots. We're going to use a thinner tool, or a thinner line than that. And we have it. And I just need to correct mine a little bit so it's actually on the line. All right, and there we go. We have our line graphed. All right, we're going to go to the next page now where we have some uses for intercepts. So our story here is in what became known as the flu game. The undisputed GOAT, Michael Jordan, scored 38 points against the Utah Jazz despite having a 103-degree fever. His points that day can be represented using the equation 2x plus 3y plus 10 equals 38, where x is the number of field goals and y is the number of three-pointers. What are the x and y intercepts that could be used to graph the equation? And what do each of the intercepts represent in the context of the equation or of the question? So we're going to start off. We need to solve this. And I notice that I have this weird plus 10 here. So let's get this into standard form that we're used to dealing with right away, and then we can start solving. So we have 2x plus 3y plus 10 is equal to 38. Now we're going to start by subtracting that 10 from both sides, and we get 2x plus 3y equals 28. So if we find our x-intercept, we have 2x plus 3 times 0 equals 28. That cancels out. 2x is going to be equal to 28. Divide by 2, and my x value is 14. Now, in the context, what is this 14? Well, when we look at it, the 14, I'm going to slide that over a little bit. The 14, the x is our number of field goals. So if we have 14, that's 14 field goals. Well, if there's 14 field goals and that's the 28 points that he scored, what does that mean about three-pointers? Well, that would mean that he had 0 three-pointers. Since we don't know right now exactly what composition he made his points in, he could have made all two-pointers. He's all inside the paint, all inside the arc. He is just shooting jumpers. He's doing layups. He's dunking the ball, jump man style. So it was all inside work. That's a possibility for him to have gotten the number of points that he did that day. There's another possibility as well, though, and that would be if he only shot three-pointers. So that's going to be the context of the other solve that we do. So we have 2 times 0, meaning that he scored 0 two-pointers. And we're going to add 3y, and that's going to be equal to the 28 points that he had. So 2 times 0 cancels out. 3y is equal to 28. And then we divide both sides by 3. We get y is equal to 9.33 repeating. And that's we've defined as three-pointers. All right. And if that is what he's doing for the three-pointers, that's implying that he has 0 field goals. So when we're looking at intercepts, we're really identifying if we have everything happening with one side of the variables, what would we get? And if we had everything happening with the other side of the variables, what would we get? So 0 field goals would result in 9.33 three-pointers. Now, do we know that to be true? Could we have 9.33 three-pointers? Absolutely not. It doesn't work that way. However, that is the way we would graph this, and we would just look for actual points on the graph that we have whole numbers that would tell us combinations of field goals and three-pointers. Because this equation here is going to give us a representation of all of the points that he possibly, or all the ways that he possibly could have scored those 38 points total. Now, let's just talk for 1 minute. This plus 10 here, what could that represent? Well, what's the other way to score points in basketball? If you're not shooting three-pointers and you're not shooting inside the arc for just a regular 2-point jump shot or field goal, what other way could you be getting points? The other way is free throws. So in this game, Michael Jordan had 10 free throws. So 10 of his points we subtracted away, knowing exactly where they came from, and now we were able to solve for what the remainder of his points were that game. All right. And we're going to move on to letter B. It's a you try problem. So I want you to do this one on your own and then check your work against mine. And you're going to choose your answer for C as well. So Angelina bought a 15-pound bag of food for her dog. The bag contains about 60 cups of food, and she feeds her dog 5 cups of food per day. The function y plus 5 halves x is equal to 60 represents the amount of food left in the bag y after x number of days. What are the x and y intercepts that could be used to graph the equation? And what do each of the intercepts represent in the context of the scenario? Well, the most important piece of information here is this right here. It's the equation that we're going to work with. Now, let's substitute in 0 for y and find that x-intercept right away. So we're going to do 0 is plus 5 halves, and that's times x is equal to 60. So we have 5 halves, x equals 60. And in order to solve this, we need to multiply by the reciprocal. The reciprocal of 5 halves is 2/5. And when we do that, we get x is equal to 24. And what are we measuring x in? X is measured in days. All right, so at x equals 24 days, we know there are going to be 0 cups left. So there is no food left in the bag for the poor dog after 24 days of feeding. Now let's find our y-intercept. So we have y plus 5 halves times 0 is equal to 60. 5 halves times 0, that cancels out, and we get y is equal to 60. And we know that y is being measured in cups, the amount of food left in the bag, so that's cups. And in our scenario, this would mean 0 days have passed, meaning this is when the bag is first bought. She has served food to her dog exactly 0 days, and there are still 60 cups of food remaining in the bag, which is right there what we started with. We know that it's 60 cups of food. All right, letter C, we have farm products. So a farm is producing about 4,362 pounds of peanuts per acre. 1 cup of peanut butter requires about 2/3 pounds of peanuts. If 1 acre of peanuts is harvested to make peanut butter, the function y equals negative 2/3 x plus 4362 represents the pounds of peanuts remaining y after x cups of peanut butter are made. Which graph uses x and y intercepts correctly to graph the situation? Well, if we're going to graph it correctly, we need to find what these intercepts are. So I'm going to take my original equation and I'm going to find out what is my x-intercept. So we substitute in 0 for y and we get negative 2/3 x plus 4362. And I'm going to add 2/3 x to both sides. And I'm going to get 2/3 x on the left side is equal to 4,362 on the right. And in order to solve this, I need to multiply by my reciprocal, which is 3/2. And I find that when I do that, x is going to be equal to 6,543 pounds. Or, 6,543, and x is cups of peanut butter. All right, so now we're going to find our y-intercept. And our y-intercept, we're going to substitute in 0 for x. So we have y is equal to negative 2/3 times 0 plus 4362. This cancels out, so y equals 4362, and we're measuring y in pounds of peanuts. So now we need to figure out which of these graphs is the correct one based on the information we have. So our x value being 6,543, well, I can eliminate number 1 immediately because it has those values switched. It has the x value as being 4,000 and change, and the y value as being 6,000 and change. So we know number 1 is wrong right off the bat. Now, if we're looking at numbers or letters B, C, and D, well, letter B only has the two intercepts graphed, and it looks remarkably similar to letter C. And then letter D, it's showing us we have 4,000 and change pounds of peanuts, but we're only getting 3,000 cups of peanut butter. So we know that one's not going to be right because that's half of what it's supposed to be. Now, the reason why it's going to be the correct answer of C is because at any point in between of processing these peanuts, you could have different amounts of peanut butter created, right? So it's not just that we have only peanut butter or only peanuts. During the manufacturing process, the amount of peanuts remaining is going down as you are making more jars of peanut butter. So it is going to be letter C because this is a line. This is a continuous graph. It's not discrete. It is continuing because, again, you could have fractions. We could have, how much is it when we've got 2,000 cups or 4,000 cups? You'll be able to figure out how much of that crop is still remaining to be processed. All right, those are the end of our notes for this module, Module 4.1b. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.